Welcome to Equine Physics. Today we're looking at the topic of centripetal acceleration, as it relates to a horse being lunged on a circle. Horse lunging is a technique used by riders to train and exercise a horse, as it travels in a circle attached to a lunge line. The purpose of lunging is to exercise the horse's limbs individually, to work out imbalances in the musculature that would otherwise go unaddressed in linear motion. The person standing in the center of the circle will use the lunge line to guide the horse around them. As the horse moves in a circle, it will experience centripetal force, which keeps it moving in a circle of certain radius. Of course, the horse isn't moving on a frictionless surface, so we have to take the friction of the surface into consideration in our calculations. When a horse canters and his hoof makes contact with the ground, the force of static friction between his hoof and the ground will be felt throughout his whole body. Sometimes, if the force is too great and the horse lacks strength, he can injure himself. In this problem, we are solving for the velocity, which represents the maximum speed that the horse can travel without falling. First, we will draw a diagram of a horse on a circle and label the forces involved. We model the horse as a single point of mass held in circular motion by inward accelerating force of static friction. This is denoted by an arrow pointing inward. When we set the equation for centripetal force equal to the force of static friction, we see that the masses cancel out. We are left with the simplified equation solving for velocity. Next, we will label our known variables and use the equations to solve for the maximum speed. We will use a radius of 10 meters, a gravitational constant of 9.8 meters per second squared, and approximate the coefficient of static friction to be 0.63. We will plug these values into the simplified equation and arrive at a final answer of 7.86 meters per second, which is approximately 17.5 miles per hour as the maximum speed of the horse. Given that an average speed of a horse's canter is between 10 and 17 miles per hour, we can see that our answer is faster than the average. This speed could be dangerous for this size of circle. In this problem, we treated the horse as a single point of mass and ignored the structure of a horse's body. We recognize that horses trot with their limbs elevated off the ground in diagonal pairs, which results in all the forces exerted by the horse to be delivered through individual legs. Since the interior limbs are closer to the center of the circle, they will experience a greater centripetal force, which challenges the horse's balance. If we wanted to go a step further in our calculations, we could have measured the centripetal force experienced by each individual leg. The great force exerted on the inside front leg is one of the reasons why lunging must be done in modification. Working in continuous circular motion can be very strenuous and detrimental to a horse's joints and muscles over time. Of course, the physical concept of centripetal acceleration is just one of many physical theories which can be applied to horses. Many of Newton's laws can be applied to a rider on horseback. For example, once a rider mounts a horse, Newton's first law of motion comes into play. Newton's first law of motion states that an object at rest will remain at rest unless acted on by an external unbalanced force. In this case, the horse becomes an unbalanced force acting on the rider, and when the horse takes its first steps forward, an inexperienced rider will be thrown slightly backwards. While on horseback, the rider must constantly adjust their balance to match the horse's center of gravity, and to avoid getting thrown behind the horse's motion. This is one aspect of riding which can be hard for some riders to grasp and takes time getting used to. In this video, you can see me adjusting my body position to affect the horse's stride. Thanks for watching this video. I hope you enjoyed this compilation of physics principles as they relate to riding horses.